Hi, everybody. I'm Sean. I'm from Spotify, and I work on a team in NYC that's dedicated to test and build infrastructure. And I work in a tribe called ADP, which stands for App Development Productivity. And one of our core beliefs is that speed is like the only way that we will win in terms of like making a product that's better than anybody else, especially in the music streaming market. So a big part of what I work on and what the teams work on in ADP are around making developers faster. And today we're going to talk about how we're making tools at Spotify to help our developers write tests and run tests faster, and specifically on varying different levels. So at the unit test level, the end-to-end level, there's a few tricks that we've been doing, and we've kind of gone from like we're in our teenage years. We're kind of awkward. We've grown from like tens of developers to hundreds of developers. So these are just some real-world examples of some problems we've been hitting in the past year with our testing infrastructure. So just to add some context to what I'm talking about today, I just want to outline our testing pipeline as it kind of stands. It's somewhat simplified, but in general, this is what it looked like. So you have some code, and then your code goes into a phase which is called pre-merge. So you have a pull request, and then you start adding add people to review it, and then a bunch of jobs get kicked off that validate your pull request. And a specific portion of these jobs are related to running the unit tests and running the end-to-end tests. And then you have post-merge. So somebody plus one's your commit, you merge it, and then it goes into this next phase where you run the unit tests and end-to-end tests again. They're a little bit different. Specifically, like the end-to-end tests, there's more of them. We have a little bit more time at that point. We try to keep builds fast in pre-merge. And then there's also another scheduled cycle of more in-depth, long-running verification tests and end-to-end tests. And then eventually, everything's going to go through that cycle. And at that point, you can kind of consider yourself as in the master branch, and you'll go out with the next release. And then all these tests running actually send data back to a centralized data repository. For this specific case, we were using a relational database to store the data, and we'll get into some reasons why that's probably not the greatest of ideas. So first, in this pipeline, I want to focus on the data point. So this is kind of like the first part of the pipeline where we started to have major problems as we started to move from tens to hundreds of developers, from hundreds to thousands, tens of thousands unit tests, up to thousands of end-to-end tests. This started to become a problem. And I could kind of outline it here. So Spotify works in small teams called squads. And a squad is a cross-functional team that works on specific features and really owns that feature and makes it as best as it could possibly be, fine-tuning it, finding bugs, doing features, and kind of idealizing what they want that feature to be for all the end users. So a squad comes in very early on, and they start writing tests. And then more squads come in, and they keep writing tests. More squads, more tests. Squads and tests, they're just coming in, which is great. I love it. I love that teams are writing tests. But then all of a sudden something breaks, like there's a test that's failing. And it's not clear really at the beginning, like who owns this test? What feature is it? Who can we contact when it's broken? And then this will start to happen multiple times. So the first thing that we did to fix this was we added a new dimension of data to our tests. So instead of just reporting failures, test timings, just your basic test information, we started adding extra metadata. So we took our teams and we said every team owns the tests, and they're responsible for those tests. And at this point, you start to get into a structure where you can easily scale by adding more teams and more tests who own those tests and can actually manage them and make sure that they're running properly, or if they're failing, they can fix them. There's very little overhead for all the other teams to know who owns what. And we did this with a feature called service files. So a team, like radio, for instance, would sort of stake a claim to a specific part of our Android repositories code, All the teams work in the same repository, and they kind of just say, this code is mine, and you stick a service YAML file in, and then you claim ownership to everything within that package and below it. And then with that, you can say, here's my owner, here's my contact information, and here's tests that I own as well. So the MC squad owns anything tagged with radio. And then all you have to do is just annotate your tests with, we call it a feature tag, so it'd be like testfeature.radio. And then at that point, everything's good to go. Your feature maps to your squad. And then whenever we run your tests, we just decorate them with tons of metadata, not tons, but useful information, such as who's the owner, what the feature is, and then all this data goes into the database. And at this point, teams can start to find what they care about, and then they also know when things are broken, who to contact. So it's kind of a big, important part. Now, so we're adding more and more data, we're adding more and more tests, and then all of a sudden, we have so many build configurations and parallel tests running that the test reporting system, it just kind of to fall over, right? It's like a 5-year-old web service that's running MySQL or something like that, and it just couldn't handle the load anymore. So it's either slow or it eventually dies. And when that happened, it made all of our test suites slow. It made them fail if it couldn't communicate with the test reporting server. So the next thing we did was we took all that additional metadata and all this good data that we wanted. We created a new test reporting pipeline. So we run a test suite, and then for each test inside that test suite, we decorate it with the data that I just talked about. And then we output the reports to the CI build agent, just as like final report artifacts. And then asynchronously, we collect that data, and we create an index or document into an Elasticsearch index that allows you to easily search that data. And then we take the hard artifacts like screenshots or HTML reports or logs, and we store that in long-term cloud storage and get that off the build agent as soon as possible. But again, now it's all asynchronous. We don't have to worry about this web service that we need to communicate with. There'll be nothing that fails in this pipeline, the original test pipeline, because of reporting. And we can always go back and like re-upload the files or the artifacts or the indexes and regenerate them if we really had to. So it's all persisted at this point. So it starts to scale a lot better. And then teams can make their own customized dashboards. So every team typically has a dashboard that's pulling in information and checking to see what tests have failed and what they need to look at. It's no longer the responsibility of one central person or like, police officer. Every team can manage their own tests, and we can start to scale and let teams take responsibility for what they own. And this is just an example of like, you can click anything and go to the actual artifacts that have been generated. So for reporting, we found that actually if you make it in a way that's asynchronous, you get less flaky test runners. No more failures because of slowdown or the test service falling over. In the end, you get faster test suite execution. You get much longer retention policy on data like CI agents. It's kind of ephemeral, but now we're storing things in a long-term storage location. It's easier for failure resolution. Whenever things are slow or failing, we can no problem finding an owner to fix it. And you get customized reporting for teams. And through document-based storage like Elasticsearch, we found that the relational model was like really limiting, and we keep adding new platforms and new things that we want to track. And Elasticsearch is really good, so it's a better data store, at least for indexing and searching. So that's reporting. Next is everybody's favorite, unit tests. So unit tests they're like the base of everything that you do, right? Everybody loves unit tests. They're fast, and they're normally stable. And we actually, in our unit tests, use a framework called Roboelectric. Has anybody heard of Roboelectric? Okay, you can help me explain to everybody. But it's basically, it's like an added layer on top of a traditional unit test that allows you to test Android code without actually starting an Android emulator. So it lets you test Java-based Android code in the JVM, which is great for unit tests. So what we were finding is that we have these unit tests. They're growing at a very good clip here. So every month we're adding tons and tons of new unit tests. And they were starting to really slow down for our developers, which is really, really bad. Unit tests being the base of your pyramid, they should be super fast. Our code base was growing very rapidly, though. We have over 500,000 lines of code in the Android app just to start the Gradle configuration and get it to a point that you're running tests was getting closer to 50 seconds, 30 seconds. It depended on the machines, but it wasn't as fast as you wanted for unit tests, especially if you want TDD. It's impossible to do when things are that slow. So what we ended up doing was we segregated our tests. So unit tests, at least at this scale, when you have this many tests, tens of thousands of tests written by lots of different teams, one size doesn't really fit all anymore. So we have two different runners in Android. We have a JUnit runner, which is just a plain Jane JUnit runner that you could run any Java class against. And then we have a specialized runner, which is a roboelectric runner, which starts that roboelectric layer that I talked about. It's great that it exists, but there is an overhead to starting that environment to test your Android code. So we did a dive. We refactored some of the code. We changed the runners, and we educated all our teams on how to do this. And then we created a new tool called Infinity. So Infinity is something that allows for TDD within Android. It's a tool that is rapid in terms of feedback. You can run any JVM-based Android test within seconds. And to use it is easy. You just edit a normal IntelliJ test configuration, and you add the script at the bottom for your Infinity sync script. And then running it is also equally easy. You start a daemon, you apply a custom Gradle plugin that we made. It runs, it collects all the Java files, and then watches them with a tool from Facebook called Watchman. Once it's running, you just run the tests, and you get instant feedback. So this test just run, took about 3 seconds, it failed. Now it can go, change the code. Infinity instantly picks up that change, and then you run the test again. So this is really changing the game here. No longer do developers have to wait more than 30 seconds to run their unit tests, especially in an Android environment. They can start to work differently at this point. They can run tests really quickly and not worry about starting up an actual device to make sure that their features are working properly. So what we learned is when you start to add thousands and thousands of unit tests, you really need a nuanced set or a gradient of test runners. It's no longer everything just works or something is slow because we're using roboelectric. You need to pick the runner that fits your use case. This really incentivized squads to write unit tests. They may have been working in a way where they were building the app and then testing it, building it and testing it. Now they can just write unit tests and verify what they're working on works without going through a longer iterative development cycle. And then it also helped adopt more TDD, red-green refactor methodologies, which is pretty hard to do in Android, but if you have the proper tooling, you can make it work. So now we have unit tests, which are really roboelectric and JUnit tests, and we allow developers to run this tool called Infinity to make their testing cycle really, really fast, and it's no longer limiting them on how many tests they can write. So now let's talk about my good friend, end-to-end tests. So end-to-end tests, for us, they're the slowest point of all these tests. They're just slow. They have a lot more to do. They have user acquisition, they have to do user login, they have to do app installation. Unfortunately, we don't have one world, but if you guys could open source that, I would use it. So we're still working on this, but right now they're slow. And we can muscle our way out of it with more resources, running them in parallel. But whatever, we'll get there. And then end-to-end tests are flaky. And this was really the first major problem we had with end-to-end tests. As we started getting into the range of thousands of end-to-end tests, flakiness was just a huge problem. When your tests are flaky, you start to not really believe the tests anymore, and you start to kind of ignore them, which is just hugely hugely bad. So what we did to fix this was we created something called a Purgatory pipeline. And you can think of this as every day you pick a green commit, and once that commit is picked, you just run it continuously. You collect the results, and you store all of the test run data in an index that you can query, and then a user can find the flaky tests and put them in what we call Purgatory. And this is kind of something we lacked because all the tests were running everywhere. There's no way to get like a really good view of the common build failures. So we put together a system that would aggregate test failures, group them with the proper test failure conditions, and we're able to decide, is this an infrastructure form of flakiness? Is this a bad test? And then somebody can go in and instantly disable the test. And they use something that we call our Purgatory dashboard. You can see a listing of the files. You click the button. The test is instantly thrown in Purgatory via a YAML file in the repository. So we update a YAML file, we do an automatic merge into the master, and then the test runners start ignoring that test. But we still run it. So we run it in a separate chain. We're not going to block on that test because it's flaky. We're going to report that it's failing, and we're going to report that it's a problem, and it should be fixed as soon as possible. Eventually, someone's going to fix that test. And to make sure that it's actually fixed and it doesn't just work on their machine, they can use a tool that we've made called FlakyBot. So all you do is you just say, @FlakyBot, run this test how many X times? We recommend 100 times. If it passes 100 times, it's normally pretty good to go. So this is an example of running it. It obviously failed, and somebody needs to make more changes. So with Purgatory, we found that improved tracking, reporting, and history of flakiness is really important. It leads to pretty much zero tolerance of flaky tests now because they're just so easy to disable. If you think that you're being delayed or limited by someone else's flaky test, go see if it's flaky in the Purgatory and disable it instantly. And for us in the infrastructure teams, it really helped us personally identify what was our problem, what was the infrastructure problems. We eliminated so much flakiness, whether with emulators or connectivity problems or user acquisition processes. We were able to fix a ton of this using tooling like this. And it all boils down to collecting and aggregating the right data. So we have a solution to deal with flakiness at this point. The tests are still slow, slower than unit tests, and there's definitely a lot more of them than any other. There's more. They're not all running in pre and post merge. They're kind of segregated. Some run in pre, some run in post. A lot of them run in this verification process. So we actually did a deep dive to find out what kind of tests were running in terms of end-to-end tests, and if there was any way that we could create a new testing layer in our testing pyramid. So we have this end-to-end test portion of our pyramid. We have the bedrock, which is the unit tests, and we have QA, exploratory manual testing at the top. And these tests were becoming increasingly business critical. And with each new team and initiative, they're growing, and we're not able to sort of keep up with the speed of these tests being written in a way that we really wanted. And we thought that there had to be a reason for these tests being so important, and also the only other outlet besides unit tests that people were using to write tests to verify that their features are working. And it really boils down to something like this. So end-to-end tests, you can think of it as this environment that lets you test your feature, if you're a feature squad, against backend services. It lets you test your feature against core, which is like our custom C++ layer, and make sure that your feature works with playback. It lets you communicate with various Android services that are already pre-existing in the app when you've installed it, such as session, metadata, features service, and it provides you with content providers. And this is pretty much why we have so many end-to-end tests. So it's the only way that you could write integration tests for your feature. To do it at any other level would be either impossible for backend services or core, or it'd be extremely hard to set up the mocks. So if you do this in the unit test layer, all this kind of falls over. There's no way you can do it. So you get a grid like this. Unit tests, obviously, they're fast, they're stable, everything that you like, but they don't give you these platform-level components to integrate your feature against. And a feature is this kind of this self-contained thing that communicates with network services, other Android services, core, but there's no way to verify that you're working with those other platform-level things without building, installing, and testing the app in an end-to-end test. So we made a framework called Cassette tests. And Cassette test is really, it's best summarized as this. It's a fast, reproducible integration testing environment that uses Roboelectric to test your features against. And it's also very easy to use compared to our end-to-end testing framework. And you can kind of think of it as, instead of changing like a control panel on the Saturn rocket and launching it to make sure it works 1,000 times a day, you just use like a simulator to verify that things are working and that you're confident that when you actually need to launch, that things will work properly. You do lose a bit of fidelity in this situation, but you gain it in terms of running the test at speed and also being able to run it in a way that's totally predictable. So you can start to run lots of these integration tests pre-merge. And to use it is just so dead simple. You just, in your JUnit test class, you add a rule called the cassette rule. And once you do that, it makes sure that you can connect to backend services. It authenticates properly. It adds a router so that you can utilize backend services within your integration tests at the Roboelectric level. It lets you talk to core. We actually compiled a customized version of core that's headless, so it doesn't require JNI anymore, that you can talk to over a WebSocket, but it still lets you verify that you're working properly with playback, with ads, with session data at the feature level. You can also talk to Android services. We set up a simulated environment with all these services that you would expect when you're running in the app. And we also set up a content provider. And it's all recordable. So if you need to run this test pre-merge, then you're not going to hit any flakiness in terms of a network service being down, or it can't log in, or something like that. It's all pre-recorded. Now, there's different modes. You can refresh the cassettes. You can run the test without the cassettes. But pre-merge, we just use the files, assuming that the other services are working properly, and we'd rather, in pre-merge, run that in what we call a hermetic testing environment, something that's completely reproducible. If there's a failure, it's probably something in what you've written. And at this point, Cassette has a lot of capabilities. It lets us perform, record, and replay network requests. It lets us simulate binds to services. It lets us simulate queries to content providers. It lets us check UI view hierarchy states. It lets us support a basic navigation between fragments. We do not recommend using it for more complicated interactions between activities. And it lets you simulate app states like foreground and background. So Cassette is this middle layer between end-to-end tests and unit tests that allow you to have a fast and stable test that verifies your features working against the platform-level components that your feature uses, but it also lets you run them in a recorded way so that you can know that the test is failing for a specific reason that's related to your code. And this is just an example of a cassette test that I've written. So this is a test that tests the artist feature. So all you have to do, like I said, you extend a base class that provides you with some helper methods for navigation. You have a cassette rule to set up the cassette environment. You give the cassette environment some information about who you are. And then you set up your tests. And we have this thing called a test given when then block, which in Roboelectric really simplifies running your tests or running your assertions after Roboelectric has become idle. It's kind of similar to Espresso, which is another Android testing framework, but it's basically just making sure that you're not going to shoot yourself in the foot by running your assertions too early. So we're using a robot pattern here, so we get a robot to interact with the current fragment. We use that robot to click on the singles for an artist. We make sure that the next fragment that was started was the releases fragment. and we get the robot for that. And then we make sure that the release is loaded in that fragment. So this is a good example of small, medium integration-based test at the roboelectric level using Cassette. And since we're using Cassette, everything is recorded, and we can rerun this test again and again and again in pre-merge and know that we're going to get expected results. And this specific test is something we converted from end-to-end tests. So when we see tests that we're willing to make the sacrifices for fidelity, to speed and hermetic builds, we'll make a decision. The team can make a decision and decide what to do at that point. So these tests were moved from end-to-end testing, which are running in about 2 minutes, to this form of testing, Cassette testing, and this runs now in about 11 seconds. And we actually see a lot of teams now using Cassette, not for testing the view level, which is like the test that I just showed you. It's more for testing. They really, really like testing it with their models and their presenters. So this is kind of like leaving out that Android view hierarchy and testing up, like setting up heavy views and fragments. They just want to verify that their feature is integrating properly from the presenter level down with backend services or platform level services. So you can do things like set up a Cassette rule, set up the Cassette test. You can set up the view binder that you want to test against. And then you can do something like interact with the player, pause the playback, and then verify that your view binder is doing the things that it's supposed to do. But since you trust your view binder is updating the actual views properly, you're going to leave the actual view level test for a higher level test, such as an end-to-end test. But this gives you a reasonable amount of confidence that your feature is going to work, and you're going to catch things sooner in the testing lifecycle. So improvements. For Cassette, we really see less time spent on flaky tests. It's not really a matter of if it's flaky anymore, since it's so reproducible and recordable. You get a faster feedback loop, and instead of maybe seeing that something's broken hours later, when you make your PR, it's already failing. And it also meshes really well with existing tools. Like Infinity that I showed you before, a developer can easily run these exact same small, medium integration tests on Cassette using Infinity and get instant feedback as they're developing within, under 30 seconds. So we've just added this new layer, and this helps us scale with the level of development and testing that we've started to incur as we keep adding more and more developers at Spotify. And we're moving these end-to-end tests where we deem it appropriate and the team deems it appropriate. So the small, medium, end-to-end tests, we're porting those to Cassette tests, and these are run pre- and post-merge. So at this point, our testing pipeline looks more like this. We have our Cassette tests in the mix now. Our end-to-end tests have started to shrink a little bit just to the ones that we really, really need and want and are willing to accept that they could be flaky or we need to support them with increased infrastructure. But now there's like another hammer to use. There's this gradient between end-to-end tests and unit tests that allow you to test at a different level, like a different granularity. So just to sum up, some things we've learned, and we're continuing to learn. As teams grow, being able to assign proper test data and ownership becomes immensely important for resolution and reporting of problems. Without it, everything becomes a mess. Nobody knows who owns what, and it just makes things a lot easier when you start to add more and more teams and more tests. Since unit tests are at the base of the pyramid, you have a lot to gain from optimizing those tests. Just don't assume they're as fast as they can be. You can have different kinds of test runners. Like Mockito, for instance, we were overusing Mockito a lot. It was incurring like 20% penalty for some mocks that we were creating. So just being able to have these different runners and educating developers on which tools to use, it really, really helped test execution times. And tools like Infinity also help immensely as well. Fight flakiness. Don't be apathetic towards flakiness. Create the tooling, the centralized data sets, the knowledge about flakiness being something that is really insidious and really is something horrible for your testing infrastructure to have. Don't let end-to-end tests be the only outlet to perform integration-type tests. There is this level of small and medium integration tests, especially when you have features that rely on other services. You can start to create these bottom-up tests to verify that your feature is working properly without having to go through an entire end-to-end testing cycle. And provide stability through hermetic tooling, like Cassette. This allows you to run more tests pre-merge and adds developer confidence that when something fails, it's failing for a really good reason, and you don't have to sort of look around or wait for the results further down the line. And that is it. Thank you.